Hello, I2K 2022. My name is Ellen Dobson, and I'm an assistant scientist in the laboratory of Kevin Elisiri at the University of Wisconsin-Madison and a member of the Imagej team. Today I will be presenting you a workshop called Introduction to Imagej. We'll be getting started with the Imagej user application. So what is Imagej? Imagej is an open source software package specifically built for scientific image analysis. This is not Photoshop. It's an end user application for doing science. It is also a reusable set of libraries and a shared framework for image analysis. Overall, Imagej has designed to be aggressively transparent, as this leads to open science. Imagej is built on others' research. It is extensible, and of course, science is the same. Being open source is all about reproducibility and transparency. Again, the aim of science. Today, we will focus on the end user application side of things, and therefore employ the Fiji distribution of the software. Saying that, there are three main flavors of Imagej. The original Imagej, Imagej 2, which is a rewrite of Imagej for multidimensional image data with a focus on scientific imaging. And then there is Fiji, which is a distribution of Imagej 2 that comes with a whole host of plugins and tools for scientific image analysis, and it also bundles the original Imagej. So everything we discuss today is in the context of the Fiji distribution. So the Imagej version 1.x is the stable original version of Imagej that has been under continuous development since 1997. This was developed as a cross-platform version of NIH Image. Now, why is this important? And what does this have to do with today's Imagej and Fiji versions? Well, our group at Madison basically rebuilt the architecture of Imagej under the hood to bring it up to date, so Imagej 2. For example, Imagej 1 can only handle 5-dimensional data sets. Now we can deal with multidimensional images coming from light sheet microscopes, etc. Imagej and Fiji have a legacy layer to keep things backwards compatible, and this is included in the Fiji installations. The aim in this was to keep the community strong and cohesive. Fiji is just Imagej. That's what it stands for. F-I-J-I. Fiji is just Imagej. But really, it's a collection of image analysis tools and plugins that was made specifically for life scientists. Everything we discuss in this workshop is again in the context of this distribution of Imagej. Now, why do we recommend using Fiji for users? Well, one, it's easy to install and update. It bundles a ton of plugins and tools as well, and there's a ton of documentation that's freely available. So what can Fiji do? Here are a bunch of the types of tools and methods one can carry out in Fiji. In general, we can open and visualize multidimensional microscopy datasets, including 3D volume rendering. We can do registration and stitching, segmentation, tracking, image measurements, and the list goes on and on. Now this is the Imagej website, which is the go-to place to learn for beginners as well as more advanced users and developers. This site has recently been updated, and it is hosted by and can be edited via GitHub. We have spent a lot of time and effort to make this wiki approachable, but it's not perfect, especially with the new updates. And it's editable, even by you. And if that sounds too scary, making edits yourself, no worries, we can just post on the forum. And that's where we're going to next. Okay, this is probably one of the most important takeaways from today's workshop, the Scientific Community Image Forum. You want to save time, right? Of course. But more importantly, you want to avoid pitfalls and do better science. So on the forum, there's a whole open source community of users and developers, as well as experts in image analysis waiting to help you. Yes, you. Even if you have an extremely basic question, do not worry, do not stress. We all need confirmation sometimes on how-tos in Imagej, right? And other open source platforms. But you can even get more involved assistance and image analysis workflows for your specific biological question. This is really the place to ask. And it's not just for Imagej. There are a whole host of open source platforms that we basically essentially aim for this forum to be a one-stop shop for all of your image analysis needs. So all of these different open source platforms use the forum to help their users. So from specific Imagej and Fiji questions to more general, hey, I just want to segment these cells and I'm not sure what to start, or even what open source platform to use. Those are the types of questions you can post on the forum. Key thing to remember at the end of this workshop, it's this: Control L, and the forum, of course. Those are the two biggest takeaways for today. This will automatically take you to the search bar. It finds commands and searches the Imagej wiki and the Imagej forum if you check those respective boxes. So let's look at the software and go to the search bar. So we're typing in here in the search bar. So let's say we want to open a sample image called blobs. It's actually hard to see right there, isn't it? So we can just type in blobs here. I'll do it again so you can actually see. So we type in blobs and we'll see there's different commands, ops, things that you can check here to search in the wiki or the forum. But the top part of the command, so we can open that sample image directly in the search bar by either clicking on run or just hitting return, right? And let's say we want to apply a Gaussian blur. We can just do it directly through the search bar, and it's way faster. For power users and developers too, the search bar can support execution of code snippets. Start writing code with a bang. Any code that works in the script interpreter should be usable as a code snippet. So let's just close these guys and we'll go back to the slides. So the search bar is really powerful, and it's pretty much the way I'm going to go through this workshop with you guys today. We know it's really impressive, right? Just kidding. All right. We know it's not so remarkable looking, but as we'll cover today, there's a lot going on in this software, and it's pretty powerful. There are three main sections of the main window: the menu bar, which is here at the top, the tools bar, and the status bar. And of course, there's still the search here on the right. The search bar we already showed you. Now the menu bar right here at the top, so let's take a look in Fiji. This hides all the different tools and plugins, all the hidden goodies in Imagej Fiji. But it's hard to remember where everything is. Like, it's hard to remember where everything is in these drop-down menus, which is why we're going to lean on the search bar today. Then there is the status bar. So if you use the status bar, you can actually, if you click on the status bar, you can see, for example, you can see the version of Imagej or Java that you're running, which is actually quite handy. So if somebody, for example, you post on the forum and you're having some sort of bug issues or something, people will ask you, well, what version of Imagej and Fiji and Java are you running? You can just click here on the status bar and see that there. Now there's also the tools bar, which is all these tools here. So for example, let's look at the line tool, which is here. You'll see there are some of these tools that have arrows, like little red arrows. And if you right click on those, that means there's hidden options there. So here we have the default, which is a straight line, but you can also select a segmented line, a freehand line, different drop-down options there as well for any of those guys that have that little red arrow. You can also double click on some of the icons and you can change some other default settings. So for example, for the line width, we can adjust that if we just double click on that icon. And then sometimes I'm sure sometimes when you guys are using Imagej, you'll notice like you have all these little individual windows that are open and you're, doing a bunch of different things. Let's just open blobs again. So we've got all these different images open, and like sometimes you lose track of the main window. You can just hit return and it'll pop right up to the front if you have multiple windows open. So that's also a handy little trick. So if you just, again, hit return, then this main window will just pop right up in front again. So staying up to date, Fiji is built upon the newest version of Imagej, and the updater is a key feature. It tells you when updates occur. Previously, you had to keep track of individual components and plugins by hand, and that responsibility no longer rests on your shoulders. This is really a great feature to really lean on. So when bugs are fixed or updates implemented, you get told immediately, and you can automatically download the newest version. Shown here is the help menu. So this is the drop down here. And update ... right here is the one that's highlighted, is the one you want. So that's the guy you want. There's another update option here, update Imagej. Now this is the updater for the original Imagej 1 version. Now sometimes that version gets updated sooner than the giant Fiji installation bundle. So sometimes there are little updates and fixes that occur for the original Imagej 1 version, and then you can just go ahead and update that before bigger releases are out there. So there's also the manage update site. So once you click on update, you can access an update site. So this is basically a web space used by the updater, which enables users to share their macros, scripts, and plugins with other researchers. So when you go to update, you'll see this button, manage update sites. You click on that and you'll see this page, and you'll see tons of different options. Here, I can show you in Fiji. Go to the help menu, update. So we're starting the updater. So it's checking for updates, and then it'll let us know if there's any updates available. Nope, see, mine is up to date. But then you go to manage update sites, you'll see this huge list of different update sites. So these are all different tools and plugins that people have made available to everybody that you can enable. So you can enable an update site by clicking on this box next to it, and then it will install everything and continually update it without you having to worry about it. So I would just highlight a few that are really good. For example, BioVoxel is a great toolkit. Image Science is a good one to have enabled if you use the Trainable Weka plugin, which we'll talk about later. There's a bunch of different ones. So then you just close it, apply the changes. It'll install all those plugins, and then you just restart Fiji. And off you go. So the very first step in any image analysis workflow is opening your data. So I'm sure you're all aware that there are dozens and dozens of file formats for image data, right? The scientific imaging field has over 150 different file formats that are all developed by different vendors. So for example, Zeiss has a format that's unique from Leica's, which is unique from Nikon's, and so on. Obviously, this presents a problem when it comes to the first step in most of our work, right, is opening an image. So Imagej does its best to open as many file formats as possible. And there are two ways images can really be opened. The simplest way is file open, which is also using like a drag and drop method, which I can just quickly show you. So you just take the file that's here on the screen, any file, and just drag it here to the status bar. So it's drag and drop. It'll say drag and drop on the status bar, and just let it go, and it'll open that image. It's just important to know. So the other way of opening the images like drag and drop is just file open, right? So these two methods are basically equivalent. So the drag and drop and file open. But it's important to know that it doesn't really work in every case. So if the data seems incorrect, or for example, the metadata might not be read in correctly, so dimensions can get mixed up, then move on to the next option, which is much safer to use. Bioformats. So bioformats is essentially a library for opening various file formats. So there's more support in handling different files. So bioformats basically takes care of the metadata for you. And for for tons of different file formats, it can open it without an issue. So whenever you're doing any sort of quantitative image analysis or building a workflow, I really recommend that you open your images using bioformats. Personally, 9 out of 10 times, this is what I use as my default option. Again, especially when you're dealing with quantitative analysis. So basically, this is the window you'll see when you run bioformats. You'll see here. So there's a bunch of different options here. We'll just show you directly in the software. So you can just type here, in the search bar, bioformats. Bioformats, and we'll run that. And we'll select an image. And then we have a bunch of different options here. And what's great is that you have an information window that exactly explains what everything of those options mean. So I'll just point out two that are helpful. There's the use virtual stack. So basically, this is good for big data sets, but it's important to note that if you're using this option, you're not looking at a real data set in this way. So any changes you make to the pixel data are not saved when you, for example, switch to the next slice. They're read-only images, basically. So again, any changes that you make are not really saved, but it's a good way to just take a quick look at any big data you have. You can also crop images on import. So if you have a super large, a big plane in your image, so it's like an entire H&E histo slide of tissue, but you just really want to focus on one particular section, you can crop it on import. You can also display the metadata to make sure everything is read incorrectly. So that's pretty much the safest way of reading in your data. So definitely use bioformats. So the image window, let's just go over some of the basics in the image window. So we're going to open a sample, go back to Fiji and open the mitosis example. There are different components in the image window that we're going to go over. Oh, it's really slow. Sorry. It's a little slow opening this image, this open sample. So basically there's tons of information here that's showing you information about your image right away. So actually you can zoom in and out if you just hit the plus and minus key and you have your cursor over a region. You can also zoom in based on the location of your cursor by hitting the plus and minus key. Okay, so we have information here at the top describing our image, tells us our channels, the Z positions, the T slice, like the slices in time, the size of our image. Again, the zoom factor, like I was zooming in and out, you can see the zoom factor here at the top. So we're at 300% for this size of the image. So the image type is also labeled here at 16-bit, which we'll go over in a second. The image size, like I pointed out before, this particular image is calibrated because it's listed in microns. The images at the top the information at the top will always show in pixels the dimensions, but this is a good indication that this is a calibrated image because it's also in microns. And then again, you have the different positions here listed at top for the channel, the Z slice, and then the T slice. So you can change channels and you'll see the image, the default colors are red and green. And you'll see that those change when you move between the two channels, 2 and 1. And then the Z slice positions. And then you can run the movie as well and move through those T slices, those slices through time. Okay. So that's just a little basic overview. So it gives you a lot of information, right? You can always see the position where you are in your image, the image size, the image type, and zoom factor. So let's go on to bit depth and pixel types, and what does this really mean? So bits refer to the number of possible values available for each pixel. Each pixel is a measurement, and you need to decide on a precision for that measurement. So with more precision, it takes up more space. So an 8-bit image is a smaller image than a 16-bit, for example. And so there are three main types that ImageJ will save. Is 8-bit, so integer values ranging from 0 to 255. 12-bit images and 16-bit images. 16-bit images is 0 to 65,535. So 2 to the 16 different values. The 8-bit is 2 to the 8th different values. 8-bits images are fine for just qualitative. If you're acquiring images and you just want to have like a look-see of your images, you don't really care about measuring them, 8-bit is fine. But if you're doing any sort of quantitative measurements, we really do recommend you save your images with more pixel values, so a 16-bit image. You want more levels. Now there is also a 32-bit image. 32-bit is a floating point, so this refers to real numbers. So essentially it's scientific notation with limited numbers after the decimal point, and it takes into account positive and negative values. And this is a really huge takeaway from today's workshop, is never save your image data as JPEGs. JPEGs were designed to store images in relatively small files at the expense of image quality. This is not made for scientific imaging. They weren't made for that. They were made for photographs, right? So basically it can result in lossy compression, which means that in the process of file size reduction, certain amount of image information is discarded. And we don't want that, right? We want our information in our images saved, right? Because that's the meat and potatoes of doing our analysis. So therefore, the stored image for JPEGs is not really the same as the original image. Hence, it's not suitable for quantitative image analysis. You should always save images as a TIFF file or the original file format of your particular imaging system. Luts, so lookup tables. Images are made up of intensity values, right? We just went through that. So different gray values, that we call them gray values. But you can actually assign those values different colors. So there are these things called lookup tables, LUTs, that were designed to assign different pixel values certain colors. So it's essentially, a LUT is essentially a table that assigns a possible pixel value to a particular color that is used really just for display purposes. It's only for visualization and does not change the actual value of your pixel. So I just wanted to highlight a couple particularly helpful LUTs. Grays, it's really, looking at things in gray values is the easiest for our eyes to distinguish those different levels. So by default, I always look at my images in grays. High-low is fantastic because then you can actually see over-saturated pixels in red and under-saturated pixels in blue. So this gives you a better idea of, where you might be clipping your data. And then royal is also great for dynamics and colors to again see high and low ranges. But overall, I usually either use grays or high-low for all of my visualizations. So again, getting to know your data. So there is a better way to visualize your data than just looking at it, right, with your eyes. So as you know, images are numbers and measurements. So use the histogram. This informative tool can tell you more about your image than just your eyes. So if we want to open the sample boats, and then you can open the histogram. And here you can see exactly how many pixels have what particular value in your image. And you can see how your histogram looks if you're over or under sampling it. So you can move the cursor along and it tells you the value at that particular point and then the number of pixels in your image that have that value. So it's really helpful to use this histogram because if you, for example, your images have the histogram that looks like this is a problem, right? That means you're oversaturating a bunch of your pixels and therefore losing data. All this data, all these numbers here that would be gone, right? You're clipping your data. So there's also plot profiles. It's another great way to examine your data. So the line tool is just another option you have to numerically plot your data. So let's open the blobs example, and we're going to draw a plot, profile plot across that image. So I'm going to open blobs, and then we just select the line tool, and we're going to draw a line straight across maybe two blobs, okay? And then we're going to plot this, plot profile. Okay, so if we're looking here we can see the profile. So basically the pixel values along that line that I just drew, right? So you can see the two blobs here. But do you notice anything that's kind of a discrepancy between what we're measuring here in the plot and what the image looks like? There's a little hint at the top of the window in the description of the window, right? It's right here, inverting LUT. So these dark images, these dark blobs, which normally we consider dark pixels to be lower value, actually have a higher value than the background, which in this case is white. So you can simply just switch the LUT, invert it, and now the eyes match up with what we're measuring. So I just wanted to just put this out there, right? The LUTs can be changed, and it doesn't change the actual data set. So if you actually move the cursor, you can also see in the status bar the value of that pixel. So here you can see it's like 140s and over 100, 200, and then the background's around 40 or so. And that's what we see in the plot profile. So now these two things align. Okay. Oh, and also there is a plot in Z axis as well. So you can plot a profile in Z. Okay, so for 2D visualization, these next few slides are just highlighting a few helpful features in Imagej. So let's just open the mitosis sample again. Takes a little while to open. It should be a little faster this time. So obviously red-green probably isn't the best color combination. There's a large population of people a significant enough population of people that are red-green colorblind. So let's switch that first channel instead of red to magenta, for example. So you can actually just type in the search bar magenta, and now we can just switch that color, right? So now it's a little bit more friendly. There's also the channels tool. Channels tool. So now, right now we're seeing it as a composite. We're seeing both channels at the same time, but maybe you want to look at, for example, just a single color one at a time as you're examining your data. So then you can open the channels tool and just select color and choose the channel that you're viewing by checkboxing or checking this box. Then there's also different composite options as well. And then a grayscale. So if you want to look at each individual channel in grayscale, which again is best for your eyes, right? To really distinguish the differences. And then also, since this is a movie, right? So this is over time. If you right click on the play button, you get different options. So you can actually speed the movie up. You can start a recording, things like that. So that's a helpful option there as well. And then finally, we have properties, image properties. So this basically just gives you a quick overview of various properties of your current images stack. So it gives you the number of channels, the slices, the frames, the measuring unit in pixels, if it's calibrated or not. You can see that in the voxel depth as well. So you can definitely see how many dimensions does this image have. Yes, it has 5, right? X, Y, channel, Z, and T. So ImageJ was designed, again, only to be able to open 5-dimensional data sets. But so if you have more dimensions than 5, then you want to use, for example, the Big Data Viewer. There's other tools that you can use to open those data sets, and Big Data Viewer is one. It can handle images with arbitrary dimensions. Okay, so for brightness and contrast, you can adjust the brightness and contrast of your images to improve visualization. Again, this only affects visualization and not your pixel values. So if we open boats and then the brightness and contrast, so let's do that. So we'll open boats and the brightness and contrast. So there's a shortcut, Shift-Command-C, or you can type in brightness and contrast here too in the search bar, but I always use the keyboard shortcut, which I think it also describes image adjust. It shows you what the shortcut is too in the window. So Shift-Command-C on a Mac. So you can adjust the minimum and maximum here. You can also auto display, so it'll fix it, or basically automatically calculate it. But again, this is just for display purposes, right? Just for us looking at the image. Sometimes it can happen that if you open an image and all you see is black, like that happens to me when I've opened data sets and they're just completely black. A lot of times this is just a brightness contrast visualization issue. So ImageJ just didn't visualize it correctly. So you can adjust the brightness and contrast by just opening this and hitting auto, and then most of the time your data is there. You can also just hover over your image too with your cursor and look at the pixel values on the status bar as well. Okay. Thresholding. So this is like, it's probably one of the most common tasks that you do in image analysis, because in most cases in analyzing image, you want to separate out objects of interest or foreground and background, right? You want objects from non-objects. What are cells? What is background? Things like that. So basically applying thresholds. So image adjust threshold is right here. Image adjust threshold is the simplest means of doing this. So let's just look at an example using blobs. Right, so we want to we want a threshold right here. Okay, so we can actually adjust it. So in this case, we have not a dark background, we have a light background, right? Because it's an inverted LUT. But you can also just invert the LUT too if you wanted. But we'll just uncheck this because we have a light background and we want the dark objects. So you can adjust the threshold here manually, right? To try and select your object as best you can. But this is really dangerous, right? You really want to make sure you're using auto thresholding methods to select a threshold, because that's based on the distribution of intensities in your image. And that's the most reproducible way to set a threshold. So you don't want to bias your results. So always use auto thresholding methods. And then there's tons of different ways of calculating a threshold. So you can try all those out, but it's a little overwhelming when you see this list and having to go through and click each one and look at it. Like, how do I know which one is the best? We have this great tool called Auto Threshold, where you can just run them all. So we don't have white objects in a black background. We have the opposite. So we're going to try all. And now you've tried every single one of those thresholding methods that's listed here. So you can just kind of take a quick look at your image, zooming in and out, and see which one is the best. So for example, like percentile is not so great, right, compared to Atsu. Atsu in general is one of the better thresholding algorithms to use for more like circular data or like circular objects. So nuclei, Atsu is usually one of the go-to ones that I use. And the default option in Imagej, the first option here in the threshold, is based on Atsu. So that's, I'm thresholding the auto thresholded picture. So that one is actually based on Atsu. So that's usually for any types of nuclei or roundish objects. That's the one I use that have decent signal to noise ratio. So that's how you set a threshold. So now regions of interest. We're going to walk through the steps of this slide. We're going to open the clown example, and we're going to try and basically draw his nose. So if you just follow along with me, we're going to open the clown image. I hate this image sample. He's a little creepy. We're going to duplicate him, okay? And we're going to use this little bean, this freehand selection tool, which it's like a little bean. So you're going to try and, let's zoom in just once, so we have a little better view. We're going to try and trace his nose as best we can. So when you're tracing, if you just let go, it'll close the object. So what we're going to do is try and trace this. I'm really not that good at it. So basically, let's say we're trying to select a cell or something, right? And we're drawing it here. And then this is a second image. In this case, it's a copy. But we have another image where we're trying to do that. It's really not easy to reproduce this, right? Let's say I want you to draw the same exact shape on the second image. Like, I need to select the same exact pixels. Like, there's no way I can draw this the same twice in a row. So what you can do is actually save this ROI, which we call a region of interest, this ROI. And there's the wonderful keyboard shortcut. You just click the letter T, and that will automatically save this object to your ROI manager, your region of interest manager. This little guy is your new best friend, this little window. So now what you can do is go to your second clown, and you can basically toggle and show that same exact measurement here. So if I were to measure this object, so just clicking the shortcut letter M to measure, right? I'm not going to, well, I have certain measurements here that aren't super helpful in this case, but that's okay. I'll show you how to change those in a minute. So I want those same exact measurements on this guy. Well, now I can do it, right? Because we overlaid the same exact object. So if we click measure again, or the shortcut M, we're going to get the same exact measurements. And for measuring those different objects, you can actually change what is measured. See, I didn't have that many selections out there by set measurements. So if you type in set measurements to your search bar, you will get all these different measurements that you can actually calculate. So things that are really helpful, right? Area, standard deviation, the min and max gray values. Maybe you want the mean gray value, the centroid of your objects, the perimeter, all those types of measurements. So now when we measure, we'll get all of those guys calculated. And you can save that as a CSV file. But what's great too about the ROI manager is now you can actually save these objects. So you can save it into a zip file and then just reopen the zip file in the ROI manager, and all of those things are saved. So you can overlay them again in the future. Okay. So yep, so we went through these slides. So we tried to just measure the same exact thing. We're able to do that using the ROI manager. So segmentation. Segmentation is the process of partitioning a digital image into multiple segments, basically finding objects in your image. So defining object from non-object and background, which is what we just discussed, right? With thresholding and then creating ROIs and everything. Those are all pieces that you'll use in your segmentation workflows. So this is one of the most common image analysis workflows to carry out. So for example, you're measuring, let's say you want to measure a protein signal inside of a nucleus, right? First, you need to delineate your nuclei, and then you can measure the protein signal within those regions. So we have a whole workshop just on this particular topic because it's so common, and I have it linked there below in the slide. So be sure to check that out. Now, this is just an example workflow, a typical example workflow for segmentation that can generally be carried out. So usually you pre-process your image. You want to increase this, the signal as best as you can. First, you need to acquire a good image. But from there, you want to have a good signal to noise ratio where so you have good contrast between your object and non-object before you go ahead and apply an auto thresholding method that'll help with that thresholding step first. So you can apply different pre-processing steps, convolving your images, applying filters, deconvolving your images, all of those things. So then you can apply an auto threshold method and you can delineate your object from non-object, and that gives you this mask, right? So you end up creating a binary mask after thresholding, and then you just have basically shape information, right? So you can carry out morphological operations to kind of clean up your mask. Then you can create and transfer a selection from your mask to your original image. So basically you use the binary mask to select your region, you overlay that on the original image, and then you can do your analysis and calculate your measurements. So again, we have a whole workshop just based on this, and for sure for more details, check that out. There's also a great plugin, a tool called Trainable Weka Segmentation, and this allows the user to train a classifier to automatically find objects of interest. This is a great tool for segmentation, and it uses machine learning. It basically is you're using a collection of machine learning based algorithms, and then the user defines certain regions. For example, you draw on your image saying this is a cell and this is cytoplasm. So you choose the labeling, and then the classifier is basically trained and applied to the images to produce a segmented output. So you have all these different features that are calculated based on the input labeling that you give. So you're training this classifier in order to segment your images. This is a fantastic plugin. It's available through Fiji automatically, so you guys have it at your fingertips and can start using it. So definitely check that out. And there's more details on that in that segmentation workflow that I linked before in the previous slide. So I keep throwing out this term plugin tool. So let's maybe go over what that actually means. So a plugin is really just a tool. It's a special purpose software component that extends Imagej's functionality. So that's what's so great about Imagej and Fiji. There's a huge list of available plugins and tools that carry out specific image analysis functions. Now, Fiji comes with a bunch of built-in plugins. It has a bunch of core Imagej. There are core Imagej plugins and Fiji plugins that are already part of your Fiji installation, but you can also enable those update sites, which we discussed previously. So these are additional manually installed plugins. There are also additional manually installed plugins that are available from various online sources, but the update sites are the easiest way to access stuff. So you just enable those sites, then you get even more tools. So what are some of the different plugins that are available in Imagej? Well, one is a Fiji plugin called Coloc 2 that allows you to do colocalization. So colocalization is a measurement of the overlap between two different fluorescent labels. There are pixel intensity based methods and then object based methods, and there's plugins for both of those available through Imagej. And one that does pixel intensity measurements is colloc 2. So basically, it carries out intensity-based colocalization measurements, calculates the Pearson, Manders, all those classic colocalization measures, gives you scatter plots, does the analysis, automatic thresholding, as well as statistical significance testing. Registration is also a common image analysis method that people need. So there are multiple tools in Fiji that are available. So registration is basically the process of transforming different sets of data onto a single coordinate system, basically lining things up. So what are some of the cases that we would want to do this? Stitching is one example. You want to combine regions of overlap, right? When you're doing stitching. SPIM data sets, for example, you're imaging large 3D volumes from multiple angles. So a lot of people actually use beads, or you have internal markers in your sample that you basically use as your coordinates for mapping one view onto another. So those are some examples there. So here are some plugins available for this method. So feature extraction is one tool that uses points of interest that are automatically detected and then used for registering one image onto another. Register virtual stack slices. So this registers a stack of images using one as a reference. So you select which one is a reference, and then through the whole stack, it'll kind of line things up. TrackEM2 does a whole host of things, including stitching and registration, and it basically uses feature extraction and global optimization algorithms to do the registration. And then BeyondWarpJ. This does image registration based on elastic deformations. Now tracking in Fiji. So there's an amazing plugin called TrackMate that's available to do tracking. So tracking is basically another common image analysis method where you want to follow objects of interest over time and space. So TrackMate is a fantastic plugin that allows users to detect objects of interest and then link those objects over time and space to generate tracks. You can do automated or semi-automated tracking. You can also trace cell lineages, and there's tons of new updates that are available where they're applying more elaborate segmentation algorithms. You can apply deep learning and machine learning and connect it to TrackMate. So there's tons of great stuff out there. So check out those new updates. For 3D visualization, there are actually a whole host of 3D tools available in Imagej and Fiji. You can follow along with updates via the link below. Imagej and Fiji have been notoriously bad when it comes to 3D visualization tools, but this is really changing, in part due to the development of some of these new plugins. And one such plugin is called SciView. So SciView uses scenery as a rendering backend. There's a great deal of new development going on with this plugin, so definitely check it out. And then finally, scripting. So what makes Imagej so powerful, besides the long list of functionalities we just went through, right? And that's scripting. So why are scripts useful? Like, why do we need to go this route? Well, scripts are really awesome because they lead to reproducible science. And it also helps you document your work in code. You can also, the most important thing is you automate your analysis. You no longer have to do everything manually. You can just click above button and process an entire folder and subfolders of images, right? And the last thing is you can share that code with the world, not just your colleagues, but through your publications. You can really share that knowledge with other people. And there are many different languages that are supported in Imagej and Fiji that are used in the script editor that's shown here. So this is all the different languages that are supported. And Imagej 1 macro is really a great way to start if you're new to writing code and scripts. So we really recommend starting with the Imagej macro language if you're new to coding. It is less powerful than some other languages, but it's easy to learn and use. You can use the macro recorder, shown here, to record the things you run in Imagej and Fiji directly into code. It doesn't just record the macro language. It also records a few others. Not too many, not the long full list. But there's some other languages that it also records, so not just the macro language. But this is a great way to start because you can then open the macro recorder, click manually the commands that you want to do, and then it records those commands into code directly, and you can copy and paste them and start building your scripts in the script editor. There's also the built-in macro functions list. So this page is really essential if you're writing macro scripts. So it's basically every macro function that exists and then gives you the definition of them. So that's super helpful. So we're really not going to go into too much more detail on scripting in Fiji. Again, there is a whole workshop that's available just on scripting. And tons of resources on the wiki. So go to imagej.net/presentations, and you'll see that there are workshops on scripting as well. So I just want to finish with the mission of Imagej. So basically, we're all about creating the next generation of Imagej, and that's driven by the needs of the community. We're all about collaboration, and we want to work together across organizations, fostering open development through sharing and reuse of code. We also want to make Imagej useful and relevant across many disciplines of the scientific community, not only life scientists. We want to maintain this software. We want to preserve backwards compatibility with the existing Imagej functionality, which we discussed a lot today. And of course, we want to unify. We want to provide a central online resource for the Imagej community. And then finally, our goal is to lead. We really want to drive Imagej development forward with a clear vision. So here are some helpful resources that I hope you guys will find useful down the road. So there's the Scientific Community Image Forum. So if you haven't checked that out, please do so. Everyone here at the conference is on this thing, I think. At least most of us are. And it's a wonderful resource, a great way to learn if you're just starting out, to ask questions, just to read other people's posts and see if someone else asked a question that's similar to yours. The Imagej user guides are also wonderful, so that's a great resource that's available through our wiki. And then finally, there are all these other workshops that are also available on, for example, segmenting using Imagej, and then as well as scripting. So please check out those workshops. And that's it. Thanks so much, guys. All right.